daughter's got to draw it first, though.
All right. Which part of the atom is radiation? Just the nucleus. Okay. Major difference between alpha and beta have from gamma?
Gamma shoots out energy.
Waves, the others are particles.
Okay, so these things are,
Particles, right? That's what I understood.
they're massive, which means what? They have mass.
Yeah.
And this over here, no mass.
No mass. Oh, so mass and no mass. Okay. I got it.
This is light or heat or energy. Any one of those would be fine. And those things don't have any mass. So if you're irradiated with alpha or beta radiation, are you contaminated?
Well, until
Yes.
particles leave, yeah.
You are contaminated. So if somebody irradiates you with gamma radiation, are you contaminated?
No.
Nope. You are exposed to the energy, and now the energy is no longer exposed. You're not exposed to. So if someone who's exposed to gamma, you could like go pick them up and like carry them someplace if they needed to be. Someone with alpha and beta, you're gonna have to put a jacket on first. You're gonna have to glove up, put a mask on. You don't want any exposure to that yourself. They will contaminate everything that they touch. Isotope, old definition.
Some number. Oh, that's not what I have.
Right, same number of protons, different number of neutrons. It's the same exact element, it's got a different mass. If it's the same element, it's got to have the same number of protons. If it's got a different mass, it's got to have a different number of neutrons. 29F tells you what about the isotope. This is written in type 1, expressed in type 2, and in type 3. Okay, so what do we know about this? It's fluorine, 9 protons, mass of 20, therefore 11 neutrons. And then we've got 20F, and then we have F-20. So all of those things are, we need all that to answer this. A type of electromagnetic radiation, a type of electromagnetic has a wavelength of, great, sweet,
Didn't know what this one was.
period, sentence. Move on. What type of
Oh, what type?
irradiation has electromagnetic of 5.5? What? Yeah. Infrared? Does it work out to be infrared? Infrared. So what number is this in nanometers?
Point 0.0000.
In
Nope.
in nanometers.
Nanometer.
Nanometers instead of -9.
-9. So if I take this 5.5 and I slide it over, how many decimal places would I need to move it? 4. So blink, 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 blink. And then that'd be nanometers. So we're looking at 55,000 nanometers. Let's, why am I writing it down in nanometers? And how is that going to be helpful to us? What's that 400 to 700 nanometers?
That's what we can see.
That's what we can see. And this down here is purple, and this down here is red. So if it's bigger than 750 nanometers, what has it got to be? Infrared. So ultraviolet, violet, all the colors of the rainbow, to red, and then infrared. So infrared is longer than red. You might want to check to see if I've slid into the microwave range, but I just know from experience that we haven't gone that many orders of magnitude away. So we are still in infrared. But you can look at the chart that we had on the, in the notes, and you can see that this would drop you into infrared range. So infrared for you, you would perceive infrared as what? Just heat. Wouldn't see anything, but you'd perceive it as heat. Okay. What has more energy, blue light or green light? Blue does. How do we know that blue does? It's closer to the dangerous, more dangerous stuff, right? So the longer it is, the longer the wavelengths, the less danger, because the longer wavelengths can't do what? Break a bond. So the shorter wavelengths are better able to break a bond, and so since blue is closer to green, or blue is closer to ultraviolet, which is the first bond breaking energy source, then you have more energy in a blue. So you could say it has a shorter wavelength or closer to UV. Write all three types of anatonic notation for a potassium which contains 22 neutrons. So I've got a K, 19, and 22 would give me 41. 41. And so then K with a 41 superscript, and then K with a dash 41. You go with that? That's what we're looking for. All right, so now we want to fill in the blank here. So what's missing out of this particular reaction? What else should be on the product side? What is the mass of the thing that's missing? 14. So these two numbers in the superscript have to add up to what the number in the superscripts are on the product or the reactant side. So 0 and 14 is 14. And then what do I have to add up? What do I need the proton number to be?
7.
Yeah, so 7 plus a -1 gives me a 6. So then we're talking about nitrogen. So I've got radon, and I've got an alpha particle, and so I just back add. So 86 and 2 gives me 88, and 224 and 4 gives me 228, and 88 is element what? It's radium. Rn is radon. Yeah. No big deal. One's a gas, one's a solid, one's a metal, one's a non-metal, one's a noble gas. One reacts with lots of stuff, one doesn't react with a damn thing. No big deal. One causes lung cancer every single year, the other one never even hear about. No biggie. No worries. What needs to happen for what needs to happen with radiation for a person to get cancer? I need a bond to break. So the radiation must have enough energy to break a bond. Is that it? I break a bond and you're good to go? You got cancer if I break a bond? No, what else has to happen for you to be able to break the bond? A bond that would matter. Okay, so the DNA, it must be unwound. So mitosis isn't the only time you unwind DNA. When else do you unwind it?
Meiosis.
No. When you're making a protein. I mean, the entire purpose of a DNA molecule is to tell you how to make a protein. So if I happen to be making a protein, open the thing up, and while it's open up to copy out the protein, I slop out a different nucleotide for the one that's supposed to be in there because a bond was broken. And then when it wraps itself back up, you didn't notice anything, and then it copies itself. And then the protein it makes from that copied DNA is now the wrong protein, and the cell freaks out and could go cancerous. So you need the bond to be broken, and you need that bond to be broken in DNA, and the only way to do that is to have DNA be unwound. And fundamentally, the composition of a neutron, what do we got? Yeah, it's a proton.
Oh. I just looked
You just looked up what?
Oh, I just looked up the, what it said in the book in the back of it.
What did it say? Gave you an
It
atomic
said-
mass
it
of
said
1.00.
atomic particles with a mass of 1 MAU and a zero charge found in the nucleus. That's what the back of the book said.
Yeah, that's not enough information for us.
Okay.
We need to know what it is, and it's, how do we know it's got an electron? Because electrons come shooting out of the nucleus, and then the nucleus's charge goes up by 1. I gain a proton, so it came from a neutron. Okay.